back to Bites of Pi. Today we're covering the third video in the 11's Lab series for Advanced Placement Computer Science. We're not going to do a lot of work today, but we're going to cover the basics of the 11's Solitaire game. Now you may be familiar with Solitaire. If you've loaded up Windows 10, you've noticed that the Solitaire collection has a ton of different types of Solitaire games. You may be familiar with classic Solitaire. If we say Solitaire, you're probably remembering all these different positions where I have these 7 positions down here on the board where I have stacks that I have to clear out the deck, and I have these 4 positions on the board that I have to fill with each different suit. Well, the 11's Lab is a flavor of Solitaire where it has positions on the board, and the whole goal is to get rid of the deck. So you may see a lot of similarities between the regular classic Solitaire and 11's Solitaire. And it's trying to suggest that I put the ace right over there. So you essentially want, the goal of the game is to get rid of the entire deck of cards in some form or fashion. So let's get into what 11's Lab is. If you go over to the activities 6-7 in your where your code is at, you will see the 11's Lab. This is essentially the whole application already pre-compiled for you, and it will pop up this game. So essentially it looks, it's a kind of a low res copy of Solitaire, but the goal is very similar. The goal is to get rid of your entire deck of cards. Again, if we're using a generic deck of cards, that's 52 cards you have to get rid of. And the way you get rid of them is different. You have to match things up, and in this game you have to match things up in either a pair of 11 or a jack, queen, and king. So essentially I have 9 cards from my deck dealt out to the board initially, and now I have to make pairs. I have to pair 2 cards that add up to 11. So here you see I'm selecting a 10 and an ace. That'll add up to 11. 10 and a 1. 10 plus 1 is 11. And I replace them, and they get filled in with 2 new cards. So again, there's another 10 and an ace. Replace those because that adds up to 11, and it gives me 2 new cards. Let's see, what else can I do here? I can do a 5 and a 6. Let me see if I select 6, select 5. A 6 and 5 add up to 11. Now you'll notice other features of this game. So say I select 2 different cards that don't add up to 11, or maybe even 3 or 4. I can hit replace, and it'll I don't know if we can hear that in the video, but it audibly told me that I can't make that combination. I have to select a combination of 11 or a jack, queen, and king. So let's continue on. Let's see what would add up to 11. I believe, nope, 7 and a 4. 7 and a 4 add up to 11. Replace that. 5 and a 6. Continue to replace. Things are looking great so far. 9, nope. 8 and a 3 will add up to 9, or sorry, add up to 11. And now I hit this position where sorry you lose, because there's no combination in this set of 9 cards that I can play that either is a jack, queen, a king, or something that are 2 pairs that add up to, or 2 cards that add up to 11. So let me continue on playing this. Notice also here it told me the game already looked ahead and said there's no way I could make a pair or the jack, queen, king. So it let me know ahead of time. Sorry you lose. It also is keeping track of how many games I've won. I'm going to speed up time. I'm going to restart the game, and it'll deal me a whole other set of cards, and I'm going to keep playing until I get through the deck. Oh, one other thing, notice here it tells me how many undealt cards remain. So it always keeps track. Out of 52, 52 plus 9 is 43 plus 9 is 52. So you know that I have 52 cards in my deck. I'm going to keep playing till I'm almost down to winning, but it'll keep track of how many games it'll take me to win. So be right back. Well, I'm almost done with this game, so I'm going to start recording again. Now you notice it's been pretty punishing. I had to lose 11 games to get to this point, but hopefully I'm going to win this one, so keep following me. Now, one thing to notice is that I can only do a pair that matches up to 11. I can't do 3 that add up to 11. It has to be 2 cards that add up to 11, or it has to be a Jack, Queen, and a King. So a 9 and a 2 make 11. A Jack, Queen, or Jack, Queen, and King make 11. Let's see, and 7 and a 4 make 11. 10 and a 1 make 11. Jack, Queen, and King. Now notice as there's no more cards left in the deck, but there's still cards left on the board. So I haven't won just yet. I still have to match these things up. 6 and a 5, 2 and a 9, and 4 and a 7, and it lets me know that I've won. So that's the basic. That's the basis of the 11's card game. It's fairly simple and straightforward. There's not a lot of skill. You just have to be able to match up pairs and Jack, Queens, and Kings. What we're going to do now is we're going to cover. I'm going to keep this over here. We're going to cover. Let's restart a game. The key features of it. Before you go into programming, usually what you would tend to do is write up use cases, and that's essentially what is a program supposed to do, and you can build off of that. It's kind of like pseudocoding your program before you actually start putting any code onto here. So here is what are some key features of this game that we have here. Well, first off, we have to define, as we said in like the last few videos, we have to define what types of cards we're using. We're not using Uno cards or Skip-Bo cards. We're using generic cards. So, and that means we have to define the rank, the suit, and the point value. Here we said that, if you remember to our last video, we said that we left Jack, Queen, and King 0 so that they can't pair up with anything. We can't pair them up with something and get 11 by accident. Jacks, Queens, and Kings can only be paired up by themselves. So we're going to give them a point value of 0, and everybody else's point value is going to be whatever is on the face card, is on their card. How many positions are on your board? Well, in this case, we have 9 positions on our board, but we could make it 8 or we could make it 10. So it depends on how much leverage we want to get, how easy we want to make it for the player. Do we want to give them an additional card to have an extra chance to make a group matching, or do we want to make it even harder by reducing how many cards they can play? So we want to know how many positions are on the board. We want to be able to start a new game. We want to be able to deal a first set of cards, so we want to take a deck of 42 and just deal the first 9 out, or however many positions there are on the board. We want to deal the cards into empty positions, so whenever I replace something, say I was to do let's see here, what am I, 7, no, Jack, Queen, and King. So when I select these, I want to replace them and deal new cards into those slots. We want to be able to tell if we've won or not. As you can see right here, after I replaced those values, it evaluated the board again, saw that there is no possible combinations, and told me, nope, I lost. Is another play possible? This is another. Have we won? Probably uses another play possible. It needs to know what value combinations are, what's a valid combination of cards on the deck. It'll take all the cards in the board into account and say, is there any other playable move? Is a certain set of cards a legal move? So if I picked 2 cards and I hit, well, let's hit this. If I picked 2 cards and I hit replace, if you heard that sound, it'll tell me that's not a valid move. If I went and selected 7 and 4, it will be a valid move. So I need to be able, the program needs to be able to tell if whatever I've selected is a valid move or not. So that also gets down to these other 2 functions. Now we have to define what is a valid move. Well, we said in our explanation before that either a group has to be a Jack, Queen, or a King, or it has to add up to 11. So we have to know if it's a selection of 3. We have to know that it has a Jack, Queen, and King, or 11. Now we're going to make this generic because we can use these functions in either function if a play is possible or if a set of legal moves. If another play is possible, this whatever function this is can use all the legal moves. So I've defined all my legal moves here, and I'll give it the entire deck on the board, and it'll say, is there a Jack, Queen, and King among these 9 cards, or is there an 11, at least one 11 among these cards? If it is, return true. If it's not, return false. And I can also, because I'm allowing it for any set of cards, I can also pass it this in legal move. I can pass it if it's 2, see if it's a Jack, Queen, and 11, or if it's 3 cards, Jack, Queen, King, to make sure that it's only those cards and nothing extra. Also, you'll find as you go through, there are certain tasks the program needs to do, and do them repeatedly. So you don't want to have to keep coding up the same logic every time. You want to be able to create that logic, put it off into a function, and reuse it in other functions. So some of the common things that you'll probably want to do is get a position on the board. So if I say return me position 1, 2, 3, 4, 5, 6, give me that card that's at that position. So I'm going to say pass in index 6, I expect to get the 8 card back. Or if I pass in position 7, 8, if I pass in position 9, I want to be able to get this 9 card. Get positions of cards left on board. If I get down to less than 9, there's going to be some cards that are null, that don't exist anymore. I want to be, at any time, I want to be able to get all the positions that are left. So if this and this are gone, I want to be able to get 1, 2, 3, 4, 5, 6, and 8, or 6 and 9. I want to make sure that I know that I don't have these left. So I'm getting a collection of those that are left. Deal a card to a position on the board. So when I remove 2 cards, I want to be able to deal something off the top of the deck and reduce this number of cards. I want to be able to tell if the board is empty. I also want to be able to tell how big the board is. And also, it would be nice to have is to give me a text if I'm debugging or if I'm kind of working through my code. Sometimes rather than having to kick off this little GUI, I want to be able to get a textual representation of the board. Now that I've defined in English English, what I want to accomplish or what are key features of the board that I want to play, I'm going to kind of pseudocode it out. So I'm going to unhide this. So if I wanted to define, here are methods that we're going to have on our 11's board. Or methods are actually not just methods, but parameters or variables. And variables. So as we talked about in the other 2 videos, we're going to have to define what kind of cards are we using on the board. I need a variable of rank, suit, or point values. How many positions on my board? Well, I'll need to have a constant board size, a number that I can put there. Starting a new game, I'll just create have a function that says new game. Deal the first set of cards, deal my cards, and so on. So I'm creating different functions that kind of encapsulate what use cases I want to cover. So what they give us in 11's is they give us they do a lot of that work for us. So let's pull up, if you go back to that activity 6 and 7, there's the 11's board. And we're going to cover some of the features on there. So if you remember, we talked about the board size, define the types of cards, and how many positions on the board. So we're defining our member variables for the 11's board. I've got a static int board size that it has the value 9. Now I can reduce this to 8, or I can reduce it to, or I can increment it to 10, depending on how difficult I want the board to be. Here's the rank, suits, and point values. Note that we have ace through king, spades through clubs, and note that I'm got the point values all the way up to 10, but I'm going to set Jack, Queen, and King to 0 so that I don't accidentally add a Jack, Queen, or King into a pair of 11. And finally, there's this Boolean I am debugging. We won't cover that here, but sometimes it's good to have a debugger that you can turn on and off as you're trying to figure out where the issues are in your code. This is also familiar to you, an array of cards. This is an array that tells you how many cards are on your board, and a deck of cards that you're playing from. You're going to empty this deck out. Here's the constructor. They've already done this for us. They've created a new board. The board is essentially an array of cards of the size of the board. They've created a new deck of the 52 cards that we're going to play with, and they're going to deal the cards. The cards at, remember, is given. This is kind of like a maintenance function. If I give it a position on the board, I want them to return a card. The card indexes. This will tell me how many. This function will tell me how many cards are left on the board. So here you can see that cards is a list of 9 cards that we have on our board. It'll loop through, and if the card is not null, so again, this is an array of cards. Whenever we wipe out a card, or we don't have enough, we run out of cards and we don't have enough cards to put on our board, we're going to replace that with null. So essentially this is counting up all the positions on the board that are not null, and it'll return that as an array list of integers. These aren't cards, these are integers. These are just positions on the board. They're just telling you what positions are still have cards in them. Here's the deal function, where we're going to deal a card to the kth position. So if I have position, say I replace this and I replace 10 and 0 and 1, the 0 position and the 1 position, and I hit replace, that deal is going to be called twice to deal a new card into the 0, and to deal 0 will be put in here, and it'll deal it into the 0 and the 1 position. Deck size. This will tell me. This gives me this part of the program. Notice my deck size now is 39. If I bump that up, if I get rid of 2 more, it's going to deal two cards from that and make it 37 left. That's where I'm getting my deck size. The game is won. Well, every time that we replace something, we have to check to see if we won the game. So remember that you won or you lose message. We need to make sure that we know if we won or we lost. This is very similar to the card. Well, let's go through the game as won. So it's basically saying if the deck is empty. So we're checking to see if there are no more cards, undealt cards, and it'll loop through the board and see if there are any non-null cards. It'll say, is this null? Is this null? Is this null? We'll know that we've won the game when all of these cards all these positions are null and there are no cards left remaining, and that's what this is doing right here. So this is the is empty is a subset of that, where it just loops through the board and counts how many nulls are there. The new game is fairly straightforward. It takes the new deck, or takes the existing deck and shuffles it again, and it deals the cards to the right positions. So that's if I go to this restart function, it called that shuffled it to a different position, positions, and then dealt them out again. I can keep hitting restart, and that'll be calling a new game every time. Replace selected cards. So here I have a list of cards, and I'm going to deal new cards into them. So again, that's if I select Jack, Queen, and King. So this is position 1, 3, 0, 1, 2, 1, 3, and 5. So I'm going to loop through these. I'm going to pass in 1, 3, and this function will pass in a list of 1, 3, and 5, and they'll get dealt new cards to them. So boom, I just called this passing in 1, 3, and 5, and it dealt new cards into those positions. The size, this just tells you the size of the board. Again, there's 9, so it's kind of redundant. And this is the debugger function, the toString. Again, we talked about this down here at the bottom. If we ever wanted to have a textual representation of the board, we'd call this, and it would print out what cards are on the board. Here's where the meat of the logic is happening. We need to know if another play is possible. If given whatever's left on the board, can the player keep playing? You know, is there a legal move left on the board? Out of all the cards that are left, is there a legal move left to happen? This is slightly different. It is legal. So you're given a set of cards. So essentially, every time I select, so this first one is evaluating the entire board at all 9 cards. Is there any combination that will give me a legal move is a legal move? This is legal will evaluate what I've selected. So if I select 4 cards, it'll automatically know it's not legal because I can't have more than, I can't have a grouping of more of 4. If it's 3 cards, it's got to be a Jack, Queen, King, or if it's 2 cards, they have to add up to 11. So that's what this is legal means. It basically is evaluating all the selected cards that I have, and it'll determine whether it's a legal move or not. This one will say, is there a legal move anywhere in here? This one evaluates if there is a legal move, if I've selected a legal move. That leads into something specific to the 11s, is what we defined as our legal moves. It's a Jack, Queen, King, or an 11. So we're going to make, because these 2 pieces really need to know, really kind of use the same thing. They use legal moves in them. We're going to make it generic, and we're going to have it applied to both of these functions. So given any group of card, so what the function will do is say, given any group of cards, so I'm going to pass in a select cards, and it will return true if there is at least 1 Jack, Queen, or King. So if I pass the entire board to this function, it'll tell me whether there's a Jack, Queen, and King hidden somewhere in here. If I pass in a selected set, it'll tell me if that selected set is a Jack, Queen, or a King. So no matter what I pass in, whether it's the whole board or just a selection of it, it'll tell me whether it has a Jack, Queen, King in there. Same thing with the pairs of 11s. If I pass in a whole set of cards, it'll tell me if there's at least 1 pair that has 11, or if I select 2 cards, is that 11. That's the main. We're going to be implementing these functions in our next video, but I wanted to point those four pieces out. This concludes the 3rd video in the 11 series. Thanks for watching.